Hey, so say you wanted to graph some exponential and logarithmic functions using some transformations of graphs. So let's just real quick review what a just standard exponential function looks like. So say we have f of x equals 2 to the x. We found out that every standard exponential, so 2 to the x, 3 to the x, all of those, goes through 0.01. As we went to the right and we put in higher and higher x's, they started going up to the right, and as we went to the left and put in negative x's, they turned into fractions and got closer and closer to 0, but never actually hit 0, so we had something called a horizontal asymptote. Okay, so let's see what happens if we try to move this graph. So say I have something like f of x equals 2 to the x plus 3 minus 4. So the first thing I notice is I have a plus 3 that's inside the function because it's with the x. It's in with what's happening to the x. So that's going to make it going left to right, and it's going to go opposite, so left 3. I get the minus 4, it's outside the function, so it's going to go down 4. So I'm going to take this graph that I drew over here, the 2 to the x, I'm going to move that left 3. So 1, 2, 3, and down 1, 2, 3, 4, 4. So again, I'm going to just draw into 0, 1 point just so I can see. I'm going to move that 0, 1 point left 1, 2, 3, and down 4. 2, 3, 4. So I'm going to, at 0, 1 point now, actually move to negative 3 in fact. From that 0, 1 point, I'm going to try to redraw this graph. So I'm going to have it go up to the right. So I'm going to have it go up to the right. And I'm going to have it flatten out toward the left and go pretty much straight flat. Which means my asymptote now is no longer at 0. My asymptote also moved left 3. Moving a horizontal line left doesn't do anything though. And moved down 4. So my asymptote now is at 1, 2, 3, 4, negative 4. Okay, so let's fill in some things. Say I want to know the domain, the range, the horizontal asymptote, the vertical asymptote, and just for fun, say I also want my intercepts. Okay, so the domain of this still goes all the way to the left and all the way to the right, so my domain will be negative infinity to infinity. My range, it does not go all the way down. It actually stops at negative 4. It goes down negative 3 and a little bit below, but it never hits negative 4. So negative 4 with the parentheses up to infinity. I have a horizontal asymptote, it's at negative 4, so y equals negative 4. And I don't have a vertical asymptote, so I'm just going to write none. Now say I want to know my intercepts. I know how to find my intercepts. I put in zeros. Intercepts are your zeros. So if I put in 0 for x, I'm going to get 2 to the 0 plus 3 minus 4. So 8 minus 4, so 4. So I should have a y-intercept. I put 0 in for x, so I should have a y-intercept at 0, 4. So let's see. Okay, it looks like I kind of do. So my graph actually isn't all that horrible. Okay, so let's try the other one. Say I put the 0, this would have been what f of x equaled. F of x can take place of y. So let's put in a 0 for the y. I'll get 0 equals 2 to the x plus 3 minus 4. Now this looks weird. We haven't seen an equation like this before, so I'm going to write it like we've seen the other exponential equations. So 4 equals 2 to the x plus 3. And now I know how to solve this. Get a common base. So 2 squared equals 2 to the x plus 3. If I got a common base, I can let the exponents equal each other. So x equals negative 1. And again, that's my intercept. So I had a pretty good graph here. Okay, so that was fun. Let's do another. So say I get f of x equals 3 to the x plus 1 minus 3. So now this 3 here, my initial 3, doesn't change much. It still, remember we graphed the previous ones, it still has the same shape as 2 to the x. So I'm just going to still redraw that shape. Okay, so the plus 1 is going to move it left 1. The minus 3 is going to move it down 3. So I'm going to take again that 0, 1 point, I'm going to move it left 1 and down 1, 2, 3. So it's actually going to end up at negative 1, negative 2. So it's going to shoot up to the right and flatten out to the left. My asymptote, again, also shifted left 1, which didn't do much to the horizontal line, and down 3. So my asymptote is now at -3. So if I find a few things, again, domain, range, horizontal asymptote, vertical asymptote, you can find the intercepts if you choose. You might as well for some practice. Domain in this one, still -infinity to infinity. Range, it does not go all the way down. It starts at -3, but never hits -3. And it does go all the way up, so to infinity. Horizontal asymptote, y equals -3. And no vertical asymptote. If you all choose to find intercepts, which again, you might as well, your intercept should be at, if I put in a 0 in for x, I'm actually going to get a 0 for y. So I actually only have one intercept, and my graph is off then. So I'm going to make my graph go up a little steeper, because it should go through 0, 0. So the intercepts are a good way to show you how, or give you a hint on how steep your graph should be. Okay, so now log of x, we graphed that in a previous one, and those went through 1, 0, went up to the right, and then kind of went down steeply to the left. So that way my asymptote this time was on my y-axis. So let's go ahead and see what happens if I shift these. So log base 2, as we said with the previous one, the bases aren't going to matter. It's still going to look about the same. We're minusing 3, so we go right 3. We're adding 1, so up 1. So I'm going to take that 1, 0 point and go right 1, 2, 3, and up 1. And I'm going to redraw the graph. So I'm going to go up to the right and then really steeply down to the left. My horizontal asymptote is also going to move right 3 and up 1. Moving up 1 should not really affect a vertical line. Okay, so let's go ahead and find domain, range, horizontal asymptote, and vertical asymptote. So my domain of this, it does not go all the way to the left. It goes all the way to 3. And it doesn't actually hit 3. So 3 to infinity with parentheses. My range, it does go all the way down and all the way up. So -infinity to infinity. I don't have a horizontal asymptote, but I do have a vertical asymptote, so x equals 3. Okay, last one. Again, the base is not going to matter as much. All it does is tell you how steep or shallow it is. So let's see, the +2 is inside, so it's going to go left 2. The +3 is outside, so up 3. So I have my point, 1, 0. I'm going to move that left 2 and up 1, 2, 3. My asymptote also moves. It moves left 2, so now it's at -2. And up 3, but moving up 3 should not really affect a vertical line. Okay, so I can redraw my graph. And again, domain, range, horizontal asymptote, vertical asymptote. And again, I don't have a horizontal asymptote, so I can put in none. My vertical asymptote is at -2, so x equals -2. My range then would be No, my range is all real, so all the way down, all the way up. Got range and domain confused for a second. And my domain then would be -2 to infinity. It doesn't ever go past -2. Okay, so hopefully moving these things around works for you. We'll move on to operations with functions next.